All right, hello, my name is Olivia Perez, and this presentation is for KIN 656, and I'll be doing my presentation on the influence of drag forces during swimming. And starting off with the most important thing is going to be how to calculate the drag force, and provided is going to be the drag force equation. And in this equation, it's going to be measured in units. The units will be newtons, and then the p-value is going to be the fluid, so the water density. And the coefficient of drag is actually unitless, and there are different characteristics and applications of drag force that is applied for different characteristics that encounter during swimming that we'll talk about soon. And then we also have the frontal surface area, and this is meters squared, and then the velocity squared is the swim velocity meters per second. So now, what are drag forces? Drag forces are actually separated into two different forces, resistive drag force and propulsive drag force. And resistive drag force is the movement of the cell body, so meaning the swimmer, within the fluid, as in water, is resisted by the fluid. So what we see is that this is also commonly interchangeably with hydrodynamic drag in the literature, and that is going to be the force that is opposite to the motion of the swimmer moving in the water. And there's also active drag, which is the force of the swimmer will have to overcome to maintain movement through the water. So as we see based off these definitions is that the water is resisting the swimmer. So they have to overcome these forces in order to propel through the water. And then we have the propulsive drag force. And this is the forces that are applied in the same direction as the swimmer. And this is produced by using the upper and lower limbs actions. And then this is also the technique of the swimmer from their arm strokes and leg kicking. And then now looking at a kinetic analysis of swimming, there's going to be 4 factors that we'll be looking at that are technically applied to the swimmer while swimming. And there's going to be 2 vertical forces that are applied on the swimmer, which is going to be gravity, and this is the forces that is pushing down onto the swimmer. And then there's also buoyancy, which is actually what is keeping the swimmer afloat above the water. And this is going in the upwards direction. And then we have 2 horizontal drag forces that are applied to the swimmer. So what we see is that there's propulsive drag, which is going to be moving in a positive direction, and it's helping the swimmer propel forward. So this is going to be through the previous statement of the arm strokes and then the leg kicking, which is helping them move through the water. And then we have resistive drag, which is actually the resistive forces that are applied through the water on the swimmer. And there's also additional resistive drag forces that are applied to the swimmer that we will talk about soon. And this is going to be how that swimmer will overcome those resistive drag forces. And this is also going in the negative direction, which impacts their swimming and will resist their propulsion moving forward through the water. And now drag forces, looking at the CD and A portion of that equation that was previously mentioned. So commonly in the literature, they actually have this coefficient of drag and the frontal surface area put together because they all impact the resistive forces of the swimmer. So looking at passive drag, this is going to be, and these are also additional factors that we consider as drag. So these can also be considered under resistive forces specifically. And again, passive drag is going to be where the swimmer is gliding through the water without arm or limb actions. And this is also seen as hydrodynamic resistance. And frontal surface area is defined as the swimmer's maximal cross-sectional area in a plane transverse to the direction of the swimmer. And we also have wave drag, where the swimmer is at or near the surface of the water. And this is specifically going to be where they're closer to the water. It's going to have that wave drag from the water, and this is promoting more of that drag resistive force. And we also have friction and skin drag. And this is the resistance that is produced from the friction between the water and the surface of the swimmer. And this can primarily be seen with studies concerning wetsuit utilized. And looking at that is the impact of wetsuits on swimmers. And there's a lot of literature that supports the wetsuit of the drag forces that are applied on the swimmers. And what we see is that it reduces drag resistive forces, it reduces skin friction drag, faster swim and velocities can occur, and this results in a faster performance. And then there's also lower energy costs, making swimmers more efficient and economical. However, although there are good benefits with using wetsuits, there are also alterations of the performance from the swimmer. So what we see is that there's also present shoulder constraints, and this could be due to the wetsuit if they're using a sleeve wetsuit rather than a sleeveless. And then there's also higher stroke rate and lower stroke lengths as well. And this is going to be affected as well by the sleeves and also the swimmer's technique while using a wetsuit. And other contributors that impact drag forces is going to be the swimmer's technique, like I mentioned. And this is going to be more or less looking at their performance and training. And using a wetsuit does you help. So if they are practicing before a competition and they are training when utilizing a wetsuit, this can help them understand more or less their swimming velocity, their stroke rates, and their stroke length. And depending on the suit that they're utilizing, and if it's a newer suit or if that's going to be their competitive suit, they have to make sure that they are practicing and training with that utilization, so then they can understand more of their mechanics and their techniques that they utilize while swimming, and how to better understand drag forces that they can maybe overcome during their training. And there's also drag forces are a factor of swimmer energetics. So we see that decreases in drag forces can impact swimming performance. And now you're looking at a study that actually utilized wetsuits and had a look at total drag and wave drag. But in this study, they wanted to look at what happens during the drag forces that are applied on a swimmer during the dive start of the swim. So what we mentioned before was that wave drag is going to be what's closer to the surface of the water, and that wave that is applied as a resistive force on the swimmer. And looking at the graph on the left is going to be the total drag and at different velocities when utilizing that wetsuit. And they looked at 1 meter down below the surface of the water, and then 0.5 meters and the surface. So what we saw was that during the velocity speeds, until the 2-point velocity, it stayed pretty sustainable. However, once when it started propelling forward and they got closer to the surface of the water as well, and at higher speeds and velocities, it was shown that at 1 meter and 0.5 meters, it did go up in drag, a total drag that was applied onto the swimmer, but it was not as high as it was on the surface of the water. So when the swimmer was actually closer to the surface of the water, due to more or less that wave drag that was applied on the swimmer, it increased that total drag, which is why at the surface of the water that there was more total drag that was applied onto the swimmer. And then similarly, only looking at the wave drag on the right-hand side is that it's similar as well, to where with increasing velocities, there was a slight increase in more or less the 0.5 meter, but as well as the 1 meter as well. But looking at the surface, as the velocity kept increasing, that wave drag increased even more. So that means that at the higher velocity, there was more wave drag forces that was resisting the swimmer to where they had to propel more forward. And with that increasing speed at 2.4 that wave drag was increasingly high. And then now looking at another study that actually utilized wetsuits is that they had 5 different wetsuits in this study, which had shoulder to ankle, shoulder to knee, waist to ankle, waist to knee, and just briefs. And what they wanted to see was the influence of the drag forces that was applied to that swimmer. And with the wetsuit utilization, how much more of those drag forces were applied to that swimmer with different wetsuits that were utilized. And what they saw was that the swimsuit design that actually utilized more coverage in the torso and the legs, like the shoulder to ankle and shoulder to knee, was that there was a less impact of the reducing drag forces, and it had a more improvement on the swimmer's performance. So what they noted in this study was for swimmers, utilizing a shoulder to ankle and shoulder to knee wetsuit is more beneficial at reducing those drag forces applied to that swimmer due to more coverage from the surface or friction drag of the wetsuit utilized, and buoyancy is also impacted as well for this. So now, overall, after reviewing all the literature is why are drag forces important? And what we saw is that it assists with reducing resistive forces. So this results in improvements in swimmers' technique, it lowers stroke rates and higher stroke lengths, which does improve a lot because with the wetsuits and its inability for the shoulder length, they had higher stroke rates in order to keep up with their velocities. And having a higher stroke length meant that they were able to maintain that velocity that they're swimming at and keep that performance going. And again, this also enhances performance. Understanding drag forces as a swimmer will help them understand what to overcome and also what equipment they're utilizing, as in their wetsuits. They will be able to enhance their performance, increase their velocity and distance. Aids the swimmer on how to program their training. And what they should do is when they're utilizing a wetsuit, they should always swim at different velocities and distances to have that good balance of what is going to be the most economical and efficient speed that they could swim at to keep that distance at a moderate rate. And then lowering resistive drag forces increases propulsive drag forces. So the more that the drag forces are reduced for the swimmer, it does help them propel forward at a higher velocity and reach their distance a lot quicker as well. So propulsive drag is a good benefit. All right, and thank you for listening to my presentation, and these are my references. Thank you.